Hi everyone, I'm here at the American Geophysical Union Fall Meeting. I'm here with Peter Webley from the Geophysical Institute's quasi, that's our Unmanned Aircraft Research Unit. And he's going to talk to us a little bit about beyond visual line of sight operations with unmanned aircraft in Alaska. So first of all, Peter, what does beyond visual line of sight mean?
Well, beyond visual line of sight is a term used to represent beyond the line of sight of either the pilot or the observer tracking the aircraft in the airspace. So right now, if you wanted to fly an aircraft, you have to fly within line of sight. That's line of sight of whoever's controlling or be able to take over, or the person that's supporting and observing if there's any manned aircraft in the airspace and where the unmanned vehicle is.
So right now, if you can't see it, you're not supposed to be flying it.
Unless you have special permissions.
Right.
And you can put in what are known as waivers to the Federal Aviation Administration, and they will allow you, or they could approve that, and then you can fly under those waivers beyond what the general public could fly or a US operator.
And so what are we doing at a quasi to try and help sort of advance this whole realm of these beyond visual line of sight operations?
Well, the FAA has set up these test sites around the country, of which a quasi and UAF leads the Alaska test site. And they're doing it in a controlled environment such that if the general public or another operator wants to do these types of flights, they can show in the policy that it's been tested in an environment where they can set the parameters. So we're doing the flights here, which we did in Alaska, where we're flying up to 4 miles from the pilot, which you can't see with the naked eye. You can't use binoculars, it has to be through the naked eye. And we're doing this with an automatic detect and avoid on board. So that means if there's any manned aircraft in the airspace, the aircraft will respond and go to a safer altitude to continue operations.
Wow, so it knows when there's something getting close to it, and it gets out of the way.
Gets out of the way. And then we're using a system from the ground that's tracking it like a radar would do for a manned aircraft.
So why do people want to be able to fly these things further than they can see? What's the application of that sort of thing?
There's a lot of them, if you think of Alaska or just mainly the United States in general, search and rescue is a big area of interest. Just if you think of the opening of the ocean routes through the passes around Alaska and down into the Canadian archipelago, you're going to need to operate and search areas that are way beyond what we can see from the coastline or even from a ship. Infrastructure mapping, for the example we've got here, is the pipeline, but this could be any sort of infrastructure that's over large expanses. Others are mapping in areas during a hazardous environment. Could be an earthquake that's caused building collapse, a forest fire, many different possible places where you wouldn't want to put a manned system in, and therefore putting people at risk.
Right, yeah, I mean we have a lot of forest fires up in Alaska and actually all over the United States. If you could have the edges of those mapped without putting pilots up there.
100%. Exactly.
Yeah.
So in those sort of places, they'll sometimes have a temporary flight restriction in place, which means there's only permitted aircraft in this space. But if one of those is not in place, then you still need to get these waivers and these permissions. But the aim of it is through these test sites, we can help the FAA have a policy that when a general public or somebody comes in, it's been tested for in an environment that the FAA can then approve to put into their policy documents.
Does it help maybe get the approvals happening faster eventually?
Well, it's possibly, but I think what it's going to do is it's going to allow those wanting to apply for them to know how to write them. So it makes it easier in the administrative side of approving them, because they follow the same protocol each time, using what they'll have learned from us in Alaska, where we're connected to Hawaii, Oregon, Mississippi, and Kansas, and other sites around the US, other test sites, ones in New York and North Dakota, that are doing their own particular work that fits into what the FAA wants. And then Alaska's just, we're the lead for the Arctic, being UAF being the America's Arctic University.
Yeah, so it's not just maybe on the administrative side of things, it's also helping potential users know how to use these things safely and in a way that's going to be in compliance with the FAA.
Exactly, and it's allowing the industry, the UAS industry, that's going to is already growing and is $1 billion industry and is going to accelerate and grow as these become more and more used. We can buy them ourselves online and use them as recreation or as pilots, but it's going to allow the industry to grow even further, and there's going to be add-ons to that industry. It's going to make it easier for them to use it on a regular basis. Air mobility is an area that's coming in, so taxis and passenger transportation, and then just safety management for anything that is in our rural environment.
Awesome. Sounds like we've got a lot of work ahead of us.
Yes.
And a lot to contribute to this growing
Exactly.
industry.
Yeah, it's good. It's an area growing. I'm presenting here in natural hazards, but I think this type of tool fits in all aspects of AGU, both from the atmospheric science to the volcanoes, and even into the engineering side as well. So.
Awesome. All right. Well, thank you very much, Peter, for spending a little time with
Thank you,
us. And I hope you enjoy the rest of the conference.
Exactly. Me too.